In this problem, called filling the boxes, we are going to practice finding volume. The goals of the day, GTD, woo woo, are to review surface area. Then we're going to explore problem 4.2, filling the boxes. You'll have some practice and some homework, and of course we want to have fun. So what you need are your covering surrounding textbook, open to page 82, pencil or pen, and of course your iPad, or you wouldn't be seeing this video. Hit pause, make sure you get everything you need, and when you're ready, press play again. So when reviewing surface area, let's look at an object that we're all familiar with, a Rubik's Cube. Let's just look at this first face, right? So I'll highlight that. If this is one square unit, then what is the area of that face? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So the area of that face is 9 squared units. Now, how many of these faces do you see? Well, if you look, you've got the one we counted, 1. You've got one here, 2. You've got one up top, 3. You've got one on the bottom, which is 4. And you've got one on the other side here, which is 5. And one on the other side here, which is 6. So you've got 6 faces, or 6 sides in total. And each one of those sides is 9 squared units. So if I've got 6 faces, each one 9 squared units, I can solve it 2 ways. I can go 6 times 9 equals 54, or I can go 9, add 9, add 9, add 9, add 9, add 9. 1, 2, 3, 4, 5, 6 equals 54 squared units. So when doing surface area, you're just finding the area of each face or each side of the object. So now let's look at it with a triangular prism or a pyramid. So you might have seen a pyramid or a triangular prism in the shape of a Rubik's Cube, but let's look at this one that shows all the faces. So again, we need to find the area of this face, right? Now we don't have the dimensions, so I'm going to make up some dimensions here. So we've got the base equals 6, and the height, let's say the height equals 9, right? So if we look at the area of a triangle, the area of a triangle is 1/2 base times height. So we've got 1/2 times 6 times 9. 1/2 times 54. And 54 divided by 2 is 27 squared units. So again, we look at this though, how many faces do we have? And we know that all the faces are the same size because this shape right here is a square. So we know our base is 6, we know our base is 6, we know our base is 6. And all the points meet the middle, so we know the height is 9. So we've got, how many faces? How many sides have we got? 1, 2, 3, 4. So what we can do is we can take this 27 squared units and multiply it by 4. Or we can go 27, add 27, add 27, add 27. So what we get when we take 27 times 4 is 108 squared units. But we aren't done, because what do we see? There's still this bottom, right? And to find that, as the shape of a rectangle, or a square in this case, so area equals length times width equals 6 times 6 equals 36 squared units. Then we just need to add them together. So we have 108 plus 36, and that's going to give us 144 squared units. So again, the concept is the same. You need to find the area of all the faces and add them together. Now let's look at volume. To do that, let's first watch this video.
Volume is the number of unit cubes it would take to fill a three-dimensional figure. How many 1-inch cubes would it take to fill this rectangular prism? It takes 18 1-inch cubes to fill the rectangular prism. You can also fill a three-dimensional object with cubes of other sizes, like half-inch cubes. It looks like the volume will be greater with these cubes. Is that true?
We're going to answer that question in the video, but first let's look on page 82, problem 4.2. So when we talk about volume, it says the volume of a box is the number of unit cubes that it would take to fill a box, like we saw in the video. So in the video we saw a unit or 3 1-inch cubes to fill the box, but you can use any unit, right? You can use centimeters, you can use inches, you can use feet. And in here, you can see that they are using centimeters, right? So you've got 1 unit cube, right? That is true, but it's 1 by 1 by 1 equals 1. And so with volume, you use centimeters cubed, right? Let me change the color. So you use centimeters cubed because you're multiplying 3 dimensions. So when you look at the volume of this rectangular prism, you've got 1 cube, 2 cubes, and 3 cubes. So you've got 3 cubic centimeters, or centimeters cubed. The surface area, you can essentially, because you know these are squared or centimeters, squared centimeters. So you can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 centimeters squared. Or what you could do is you could break this up into where the net is going to fold into that rectangular prism, right? So you can see that this will fold that way, that will fold that way, that will fold that way, and that will fold that way, making this shape. And then you could calculate the area of this, calculate the area of that, 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 and come up with 14 centimeters squared. So now, let's go back to that shape in the video. As you recall, it was a shape that looked like this, right? It's a box that we were filling. And it was 3 inches wide by 2 inches high by 3 inches deep, right? So we were using a unit cube, or a 1-inch unit cube to fill that, right? And as they filled it, there were across the front, across the front, there were 3 of them, right? So, and then you fill it up, and you ended up with 9 on the first level. Now the question was, when you're using half-inch cubes, it looked like the volume was going to be greater because you had to put more half-inch cubes in there. But you have to remember that that unit cube is smaller. So yes, you have to put more in, twice as many actually, because 1 inch is 2 times more than a half-inch, but the volume remains the same. You're just using smaller units. If you have questions on that, let me know. Now it's your turn. I want you to practice problem 4.2, part A, number 1 and number 2. Now you don't have a table that you can use, but you can get out a piece of paper. And so for the 3 prisms, I want you to tell me what the length, the width, and the height is of each prism, and what the volume is. And then tell me how you found it. So let's do the first one together. So we've got the length is 1, 2, 3, 4 units, right? And then for this, the width or the depth or length, we've got, it goes 1, 2, 3, 4, 5 units. And then our height is 1 unit. So those are my dimensions. Now the volume of each prism, there's a couple ways I can do this. I can quite simply count it out, right? I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I have 20 units cubed. Or I could go 1, 2, 3, 4, and then go times 1, 2, 3, 4, 5, and get 20 units cubed. Or I could go length times width times height equals 20 units cubed. All right, now I want you to do prism 2 and prism 3. Press pause here and work on prism 2 and prism 3. Once you think you have the answers, press play. You can now review the answers shown on the slide. Now let's look at the next page. So part B, Natasha and Kurt use different strategies to find the volume of a rectangular box. Kurt finds the volume by multiplying the length by the width by the height. He uses the diagram below to illustrate his strategy. So you can see that he's got his length. So he counted out the number of unit cubes, the width, and he multiplies that, kind of like we did with the 1 layer. But then he knows how many layers he uses. So he goes, volume equals length times width times height. Natasha finds the volume of a rectangular prism by multiplying the area of the base by the height. She uses the following diagram to illustrate. So similar to the way that box was filled, what Natasha is doing is, what Natasha is doing is looking just at this one layer. And she's finding essentially the surface area of that one side, right? So she finds that it's 1, 2, 3, 4, 5 times 1, 2, 3, 4, 5 times 4. And then she takes that and then multiplies it by the number of sides. So here's what I want you to do. Answer the questions below. Number 1, is either of these strategies correct for finding volume? Tell me why. Number 2, for each correct method, write a formula for finding the volume of a rectangular prism, which I kind of helped you out on the first one. And number 3, use your formulas to find the volume of a rectangular prism with the length of 12 centimeters, width of 10 centimeters, and a height of 7 centimeters. And be sure to label your answers correctly. Remember, this is just practice. You don't need to turn this in. Press pause and work on this. When you think you have the answers, press play. Is that what you got? And did you label your answers correctly? All right, turn to page 87. I want you to practice a couple more things. So look at D1 and 2. I want you to find the volume of each prism, and I want you to find the surface area of each prism. You can use a calculator. Hit pause, and once you've solved the answers, hit play.